Hello everyone, welcome back to my channel. This is second video on Jackson Crossland. In the previous video we have discussed definition, uses, followed by construction of JCC. In this video we will focus on principle of Jackson Cross Cylinder. Jackson Cross Cylinder is based on the principle of expansion and contraction of sterns of conoid. So basically there is expansion and contraction of stern of conoid. To understand this principle in detail, we need to understand what is sterns of conoid. Sterns of conoid is basically the configuration of rays formed by an stigmatic surface. Configuration of light rays formed by stigmatic surface. We know that in stigmatic surface the light is focused at two different points. So for astigmatism we don't have a single focal point, we have two different focal points. Let's consider this is an eye and this is its vertical meridian, and the green one is the horizontal meridian, this one. So the light rays passing through the vertical meridian are focused at a different point, and the light rays from the horizontal surface are focused at a different point. Let's suppose this is the focal point of vertical light rays, and this is focus of horizontal light rays. Okay, so this is the configuration that is formed by an stigmatic surface, and it is known as sterns of conoid. And in sterns of conoid we have three main things. Number one is the first focal point, this one. I will label it as F1. This is the second focal point. I will label it as F2. And this is the point where convergence of light rays is equal to the divergence of light rays from both meridians. This is known as circle of least confusion. Up to now, we have discussed an stigmatic surface having different power at different meridians. So vertical meridian focus light rays at another point, and horizontal light rays focus light rays at another point. So the configuration of light rays formed by stigmatic surface is known as sterns of conoid. This is sterns of conoid, and in sterns of conoid we have three things: F1 primary focal point, F2 secondary focal point, and then we have circle of least confusion. So now we will move on towards this, that how Jackson Cross Cylinder is basically expanding and contracting this sterns of conoid. Before you start the procedure of Jackson Cross Cylinder, it is necessary that this circle of least confusion must be on retina of the patient. If it is not present on the retina of the patient, it means that you cannot perform Jackson Cross Cylinder accurately. So before doing Jackson Cross Cylinder, you must put circle of least confusion on retina, and you can do this by finding out best VN Saphir. So first you will find best VN Saphir, and we assume that best VN Saphir puts circle of least confusion on retina. Okay, so this circle of least confusion will be on retina. So before starting Jackson cross cylinder, I have a situation like that. This is the eye, let's suppose. This circle of least confusion will be on retina. I will label it with green. This is, let's assume that it is circle of least confusion. Then I have F1 and F2. F1 will be here and F2 will be there. F1 and F2. Now the difference between F1 and F2. This shows that how much cylinder is required by the patient. Greater the distance between F1 and F2, greater will be the cylindrical correction required. And basically from JCC, we are finding out the cylindrical correction required for the patient. So far, I have discussed the basic concepts related to that, stumps of conoid. I hope that's clear. And now we will focus on this expansion and contraction of stumps of conoid. We know that this F1 was formed by the vertical meridian and this F2 was formed by horizontal meridian. You must remember that. Let's suppose the patient came to us, had a refractive error of -2 with -3 cylinder at 180 degree. When we are doing Jackson cross cylinder, we do not know the prescription of the patient. So we are estimating that we are showing cylindrical lens at different orientation, and the orientation which the patient appreciates, then we will go into that particular direction. I will explain the procedure of cross cylinder in next coming video. This video is only focused on the principle of JCC. So let's suppose the patient has this prescription and the BVS we have is, let's suppose, -1.50. Best field sphere, that we assume that it has put circle of least confusion on retina. Now when I show him Jackson cross cylinder at various positions, let's suppose in position 1 I have shown him -1 cylinder at 180, and in position 2 I have shown him -1 cylinder at 90, and I have asked the patient which position is clear, either position 1 or 2. Okay, I'm doing this just to find out the cylindrical correction required by the patient, and we know that this patient requires -3 cylindrical lens at 180. So in the first position we have -1 at 180. We know that cylindrical lens 90 degree to its axis act as spherical lens. Okay, so when we put -1 cylinder at 180 through JCC, it means that it will act as a sphere at 90 degree with power -1. So coming back to this configuration, now it will act at 90 degree meridian, which is the vertical meridian. Vertical meridian forms the F1. So here power of -1 will act, and this power will be spherical. And we know that minus spherical lens move the focal point behind. So it will move this focal point right here. Okay, so I will get a configuration like this. Here you can see that this interval was greater. Now this interval is shorter, which means that both focal points are near to each other. That is, cylindrical correction is given in a right direction. So this is basically contraction of stumps of conoid. It is basically contracted. Here it is big and here it is a bit smaller as compared to this one. And I will continue adding cylinder until I reach this prescription -3 at 180, at which I will form a single focal point on the patient's retina, and his stigmatic correction will be given. So this was contraction of stumps of conoid. But on position number 2, minus 1 cylinder at 90, it will act on 180 degree, and at 180 degree meridian it will give the power of minus 1 spherical. Horizontal meridian was F2. F2 was the focal point of horizontal meridian. It means that in this situation, minus 1 will act here, and when it will act here, it will drag it further in this direction. So we will get stumps of conoid as something like that. So here you can see the stumps of conoid is basically expanding as compared to this. So here expansion is going to happen, and we don't want expansion, we want contraction, so that both focal point can come close to the retina. So this is expansion and this is contraction. Now you must be wondering that if we know that we don't want expansion, then why we are doing this? We are doing because we do not know the orientation and power of the cylindrical lens. We are showing him both the options, and the option preferred by the patient shows us that we are in a right direction, which is basically contraction of stumps of conoid. In the last, I will add another thing. In the start, we have discussed that for JCC, circle of least confusion must be on retina. So if this is the case, where F1 moved towards the retina, you will see that circle of least confusion is not on the retina. It will also move behind. So to bring it on the retina, what we need? We need a plus lens, because plus lens can move the focus towards the left side here. So we will do this by taking half of cell edit, which in this case was minus 1. So minus 1 half is 0.50, and we will take it as plus sign opposite to this. Okay, we will add plus 0.50 spherical lens. What it will do, it will move again this stumps of conoid towards the left side. As a whole it will move. Now it will not only act on this meridian, it will act on both meridian, because it is a spherical lens. So this stumps of conoid will move in this direction. Let me show it here. After adding plus lens in the trial frame, I will get this situation. Circle of least confusion is again on the retina, but you will notice that interval of strum is now reduced. It is contracting, and we will further add cylinders till we get a single focal point. Initially, I told you that best field sphere was minus 1.50. Minus 1.50 was best field sphere. Cylinder added was minus 1 at 180. By adding this, it will become minus 1 with minus 1 cylinder at 180. Now we'll again show cross cylinder at different orientations 1, 2, and further refine the cylindrical correction. And when changing cylindrical correction, we will also change the spherical correction. The purpose is to bring circle of least confusion on retina. So this is the basic principle of Jackson cross cylinder. In the coming video, we will discuss the procedure of performing JCC. Thank you.